I would say so.
All right, so hopefully some of you are coming to game night tonight. If not, we still have room for a few drop-ins. We've got 79 people signed up. You got some extra credit. You don't have to know how to play. So 8 o'clock above the library is where all the fun starts. Any questions on that? Any questions before we get started? We continue our Love Gov episode here. We're on number 4.
Dude, that will cut your monthly utility bills.
Which one is this? This is 5. I jumped ahead. Okay, here we go.
No, I'm really gonna do it. I'm gonna buy a house.
Good! Because home ownership, that's the American dream. And everyone deserves to be a part of it. Everyone.
Would be pretty neat to have one here.
No, this is not zoned for residential.
Oh, it's just joking.
I'm gonna help you find a house in a good and proper place, okay? Hey, not zoned for residential. No domiciles here.
You're yelling at birds building a nest.
Alexis, I was just joking.
I can't believe I was gonna buy a house with him.
Everyone has a blind spot. Yours is Gov. Mine is, well, if I knew, it wouldn't be a blind spot.
Thinking people want to hear you talk about bitcoins.
Everyone wants to hear about bitcoins. The blockchain is the future of global currency. But I guess you have other things on your mind right now.
Gov. It seemed like you knew everything.
So, are you sure about this? Buying a house is a really big financial decision.
Gov thinks it's a great idea.
Oh, he thinks it's a good idea.
It's not like that.
No, it's not that I don't like him. It's just that he's kind of like a black hole sucking everything into his singularity of awfulness.
Yeah, Gov is quite a force.
Speaking of Gov, hey, Lexi, you ready to go house hunting? You're here. Well, it's really great to see that you can survive in direct sunlight.
She was just helping me make sure my price range is right so that everything fits within my budget.
Budget? What is that? Never even heard of such a word. You know what this is? This is Libby once again being focused on prices and costs. You deserve to be in a house that you want. I'll make sure you get the money you need to make it work.
But that's how we got that housing bubble. See, it's not a question of deserve. The finances have to be there too. Now, if you look at this, you can see the history
Do you mind if I just... Wow, that is great. Oh, I accidentally deleted your app. No, I didn't. Now I deleted it. Let's go get you a house. It's your right. Here we are. Doesn't it just have the cutest curb appeal?
I love it.
It's on wetlands. Don't have to have this bulldozed.
I think that's just a sprinkler.
That's for the EPA to decide. Well, on the next one. He's meticulous.
I think financially I can make this one work. I'll have to make a few sacrifices. Only buy off-brand cola, steal my neighbor's Wi-Fi. But yeah, I can do it.
Perfect. This is what it's going to cost to bring it up to code.
And now I can't.
I'm going to call my bulldoze guy. He works really quickly.
This is
Hello?
so many numbers.
Hey.
How can you tell this place is built on an Indian burial ground?
Native American. This is... No, this
this is a house.
It's a dump.
It's perfect! The outlets are the proper distance apart. It's got the mandated GFCIs. It's got LEDs and everything. And you gotta see a proper return on these heating bills.
It still seems expensive for what it is. But I guess this is the best I can maybe afford.
Let's get you a loan. I love loans. It's the best part of homeownership.
Oh, and I'll get you that paperwork when you,
Alexis, your loan has been denied.
What? Why?
Oh, you can't expect to be approved for a $225,000 loan when you're already hundreds of thousands in debt.
That's not true. Maybe I wrote my social security number down wrong. Sometimes my 4s look like 9s.
Well, my denials never look like approvals.
If it's a question of social security numbers, I might be able to scrounge some more up.
How did I get in all this debt? Can you help me?
With what?
Don't you have savings?
No.
I thought you had some high-paying job.
No, I don't have a job. I mean, I never really had a job.
So now you're always throwing money around.
Oh, I'm massively in debt. Massively. Except that it's actually other people's debt, so it's complicated.
You ran up all this debt on me?
Did you not know about this?
I'm bankrupt. You've bankrupted me.
Do you two need a moment alone? Or?
Look, however bad bankruptcy is, no matter how bleak this looks right now, I just need you to keep one thing in mind. You still have to pay back your student loans, because those don't go away.
Oh no, you haven't paid those back yet? That's not good.
Close.
Okay, so you guys ever thought that maybe some of these government policies nudge you into certain situations that may not always be benefit, and they're nudging, not necessarily nudging in a bad way with good intentions, but gotta go to college, 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 gotta go to college. Where did that message come from? Was it really your mom and dad? Or was there more to it? Gotta get a house, gotta get a house, gotta get a house, gotta get a house, gotta get a house. Was that really your mom and dad that suggested home ownership would be the best thing? I don't know. Maybe there's other people nudging things certain directions because they think they know what's better for your life than what you do. It's possible, at least. Something to be open-minded about, right? So, like to think you guys are all in control of your own destiny, and I do believe that. And that's why you're getting educated now, so that you can think your way through some of those tougher situations and make sure that it's you doing the reasoning and not somebody else, so that it's something that works for you. Okay, so we left off with elasticities. What was an elasticity? Look back in your notes. What was an elasticity? A price elasticity. Price elasticity. Let's see. Augie, give me a number between 3 and 9.
7.
7. 1, 2, 3, 4, 5, 6, 7. Janaya, you're our winner today. What is an elasticity? I'll give you a hint. I think it was the first thing we defined in our notes yesterday. And I know you were here because you got an extra credit point yesterday. You find it at the top. An elasticity. It might not have been the first thing. I can't remember exactly.
Is that yours?
There we go. Nice and loud. Yep, she's got it. All right. A number a number that shows the responsiveness of quantity demanded to a given change in price. So what we're trying to do is quantify some things. We did this graph before, and I think you guys failed miserably at it, so hopefully we'll see how far we're coming along here. Which demand curve, A or B, shows a greater responsiveness to a change in price? A or B? Which one shows a greater responsiveness to a change in price? How many people say A? Show of hands. So I got some weak hands. Be proud. And I see some online. Okay, how many people say B? Hey, all right, so B it is. Good, you guys are getting that? So B is relatively more elastic. So if we take B here, the reason we did it that way is if we take a given price change and we move from, let's go $10 to $12, the responsiveness of consumers is a lot more on B than it is on A. So on A here, maybe we move from 100 units to 90 units. And on B, we move from, let's go 140 units to 100 units, just to keep things easy here. Okay, so boom, raise the price. I'm gonna go shop somewhere else, right? Buy 40 units. Whereas here, I don't have many places to go. I guess I'm still gonna buy it, right? So inelastic versus elastic. All right, so today then, what we're gonna do is calculate that number. So I left off yesterday with a formula to calculate this. So we're gonna stick with panel B here, and I want you to use that formula to calculate the elasticity. So with panel B, the elasticity of demand was equal to the percentage change in quantity demanded over the percentage change in price. And that was equal to the new number minus the old number divided by the average quantity. And same thing with price. And so now, I can't remember if we did, I think we did, yeah. The new number minus the old number divided by the average of the two, which is 12 plus 10 is 22, divided by 2, the average is 11, or we can kind of eyeball it, right? So the average is 11, or that was price that I just did. So divided by the price of the new minus the old price divided by the average price. And then that's going to equal a number. Go ahead and turn to your neighbors. I want you to put a pen to paper and actually start calculating that. You can pull out your phone, put it on airplane mode for me to use as a calculator. We'll tuck them back away after we're done, but if you need to have a calculator, you'll have one for the test, which is next week, by the way. So we've got our midterm test coming on, so practice using a calculator so you can pull out your phone, put it on airplane mode. I'll come around the room, and you guys are calculating this number that reflects the responsiveness of quantity demanded to a price change. So we're going from A to B. So we'll call this the new number is the 12. Yes. So we'll just pretend we could go either way, and you're going to get the same number. That's why we use the average, by the way. But so we'll start at A. So this will be the new price, and this will be. I'm sorry, I just said that wrong. This will be the old price, and this will be the new quantity or the new price, and then the old price corresponds with the old quantity, And the new price corresponds with the new quantity. So all you're doing is connecting the dots, just like we did in the previous chapters.
Can we get a better angle? We can't see that.
You're right, you guys. And today, no, I'm sorry, you can't. I don't have, my other camera is tied up with the recording, so I'm going to put some of this stuff here. All right, you guys can see that all right? So there's your numbers. Go ahead and plug and chug from yesterday. All right, you need a little nudge? What's your name again? Huh? Yeah. All right, so basically you're starting here. And so take that new number, which is what? What's the number? No, not 12 for the quantity. So this is the quantity. So this is the new quantity. Which one's the new quantity? Nope, that's the old. So, I'm sorry, no, you are totally right. My bad, yes. It's 100. My brain's been going in reverse here. So we're starting at A, going to B, so it's 100. Yep. So start there, and go ahead and just replace these things with all those numbers. 100 minus 140 divided by the average of the two. And just do this. Basically, you should have this, if you want to write it right below it, that might be handy. Yeah. And I've been on the fence whether I want to keep that screen light going or not. That thing's going to time out, but I've been climbing up on the furniture for so long now. Okay, what do you got? Where you at? Let's see it. Well, where's the formula? Man, you got it. So you see that? Yeah. Okay, copy it. Oh, you don't have a pen. Somebody have a pen that you can use? I got it. He's got you. Yeah, the O would be the old.
Oh, it is now?
Yeah, I was just doing old and new. So. There you go. Now you got J right there. That's so you can pay back after. Okay, how's yours looking? Okay. That is not the average though, right? But it would be the average of those two. So it'd be 120, right? So the thing that we're doing for the percentages is always the average of each one is the denominator, is this upstairs thing. So that's the average price. Yes? Yes, you did good. So Justice just uncovered an important thing. The number's going to be negative. So it's 100 minus 140 for that top argument, which gives you a negative 40, and that's correct. It's a negative number. Okay? So you're basically taking this formula, which you didn't quite complete yet, right? So new number is what? What's the new quantity? 100, yep. And what's the new, or the old? 140. So, and then you're kind of seeing this. It's actually double division of this. So then this is the new price minus the old price divided by the average price. So that's a big double division, divided by each other. So it's like a double division. Yeah, so just, you don't worry about this, because this is the guts. This is the guts of this. So just complete that. Yep. Just plug in those numbers. Did you just step in? Okay. Get copy in. What are you doing? Okay. Yep, and then once you do that, then you're just plugging in, each one of these is going to be a number, and then the whole thing collapses. You can pull out your calculator. There you go. That looks good. And then you got enough room. I would just continue this here, and then plug in 100 minus 140 divided by 120. And this is 12 minus 10 divided by 11, right? And then the whole thing is just one big equation that collapses down.
I'm like, I can't see the
Well, you need to sit up a little closer. Yeah, come on up. Wait, why don't you come up there right now at least? You can move back if you want. Make sure that phone stays away, remember?
Oh, yeah.
How are you doing?
That's cool. I'll learn better anyway.
Yep, from this part here. And then don't forget, like, this is new medical.
762.
Because it might be a little confusing if you drop it. Okay. All right, any of you guys having problems seeing, just come up. There's some empty seats up there.
I ain't even cap on my right here.
So it's the triangle means change. So that's what this is. The new number minus the old number is the change in quantity. So you did it right, 100 minus 140. See how that's the change in quantity? And then that's the change in price. The new number minus the old number. So that little triangle is math shorthand for change. It's a little delta. It means the change in quantity. Moving from point A to point B, how much did the quantity change by? All right, so you're getting close. Yep, so you need to get down to an answer with that. How about you? Okay. So you're following this, right? So the average of those two? What's the average of those two? So you're up top here, right? Can I use your digital pen?
It's on that bitch sleep.
So you're doing this.
Well, y'all cap.
So this is, the average of these two is 120, right? So that chunk is this. You just made that. And then now you got to do the same thing down here, divided by 11. Now that piece is that piece, and then figure out the number. Okay, we got a number. Ooh, you're dangerously close. All right, now don't forget that there's a big division. Whoops. There's a big divided. So you got a big division problem divided by a division problem, right? That's what this is saying. So calculate those numbers. Negative 40 divided by 120, come up with a number. 12 minus 10 is 2. Divided by 11, come up with a number. Take that number, divide by that number, and you're home free. Okay, hold up your papers, guys on Zoom. Let me check you out. I just went through pretty carefully around the room. Just show me where you're at. I just want to see that you're doing something. Sam, you need to get your video on. I don't care if you're not done, but I don't want you just sitting there like a bump on a log. You know what I'm saying? So Dawson, Rich,
Can you
Augie.
show us the first part of the equation? We can't see that. I was trying to figure it out, but I can't read it.
Okay, it was the same thing from yesterday too. Show me your papers though. I'll be doing it in a sec. I gotta keep you guys honest. Rich, you
I'm doing everything on my phone calculator.
phone calculator. All right, but I want to see some paper and pen. So here's what's going to happen. Y'all are going to be in here for a midterm, and you're going to have nothing but paper, calculator, and pen. You're going to have to do what we're doing right now next week. So
I'm just in quarantine until Wednesday, so I'll be at class Thursday.
okay, all right.
And
So,
I left
that's-
my notepad at the school, so.
You left your notepad. All right, well, come to class. I'm sure you got, wherever you are, you can scrounge up a piece of paper, maybe the back of a receipt or something from Walmart or something. Scrounge up some paper. All right, so here we go. Dawson, did you have paper or not? All right, Jerice, did you have paper or not? Need your face on a little bit better. You got better lighting, Jerice? All I see is a hoodie and a red hoodie. There we go. There we go. Yeah. Hey, there we go. Did you got any paper there, Jerice? Jerice, you got some paper?
Yeah.
All right, hold it up for me. Hold it up to the camera. It's blank?
I'm still doing it.
You still? I know, that's okay. That's what I was saying. Even if you're in the process of doing something, let me hold it up nice and close. I'm hoping that there's more than just a blank page. All right, cool. You got something down. All right, Sam, what about you?
I'm doing it right now too as well.
All right, all right. All right, here we go. So let's get this. What'd you guys get for answers, first of all? Shout them out. It doesn't matter if you're wrong. It's okay to have wrong answers.
I got 11.
Negative 1.5 and 11. Other numbers?
11.09.
Negative 1.3 What'd you say is 0 point?
No, for the 11 one, I got 11.09.
Oh, 11.09, got you. Okay, anybody else?
Negative 1.83.
1.83 negative. Okay, anybody else? All right, so let's do it together here. Make sure that everybody's got the right answer. Like I said, you're going to have to do this next week on your own potentially. So we got the new number. So the elasticity of demand is the new quantity minus the old quantity. So I like to, some of you were doing it in pieces, and you can do it that way, but I kind of like to just have it done. We're doing 100 to 140. So 100 minus 140 divided by the average of the two, which is 120, divided by the new price of 12. 12 minus 10 divided by 11. So now we get negative 40 over 120 divided by 2 over 11. All right, so we could go, at least with my brain anyway, I can't do this math without my calculator, but I can do this.
Got it written down.
What's that? Okay. All right, keep on it. So then we got the 2, that cancels to a 20. What does this cancel to? Is that 6 or 5? It looks like a 6, right? So equals negative 11/6. And somebody with a calculator, what's 11 divided by 6? I think 11 minus 6 is 5.
It's 1.8.
1.8, negative 1.8. All right, so you might have had some rounding if you did it in chunks or something, but it looks like a couple of you, at least this 1.83, and some of these are close. And did I make an error? I mean, you guys catch me if I did. If maybe you want to do 40 divided by 20 and the 2 divided by 11, do it on your calculator. But I'm coming up with, I made these numbers up. I do not have the right answer. So I'm relying on you guys to double check that work, right? So, are we cool with 1.8? Did that check out with you guys doing some math? Okay, so negative 1.8 is the number that reflects the responsiveness of demand to a price change. So, how can we interpret that number? So interpret the elasticity of demand equal to negative 1.8. All right, so what is true? I know not everybody's mathematically inclined here, but how can you change any number into a fraction? Divide by what?
Over 1.
Divide by 1, good. So divide by 1, you can change any number into a fraction. It's like magic, right? So check it out. If we do the elasticity of demand equals negative 1.8 divided by 1, if we make it look like that, we can tell a really nice story about the interpretation, because the upstairs was the change in quantity in percentage changes, and the downstairs would be the change in price. And so now this 1 is connected to a 1% change in price, and the 1.8 is connected to a change in quantity. And now we can write a real life sentence that you can tell your boss, and anybody can probably get the gist of what an elasticity is trying to get across. And so here's how that goes. A 1% increase in price leads to a 1.8% decrease in quantity demanded. So that's a great way to interpret what this number means. So a couple things that come out of this. Justice uncovered the first one, that it's always negative. Why?
Demand curve is going slope and down.
Good. It is always negative because of the law of demand. And as, who said that? Was that Jensen? Or yeah, as Jensen said, you can also think of the law of demand means downward sloping demand curve, right? So because of the law of demand, parentheses, a downward sloping demand. Let's see, I want to keep that. Okay, so what would it be if we came over here and looked at the elasticity? Sorry that I kind of ran out of space a little bit. I wanted to make it somewhat equal here. What if we did it between A and C? What is this number? Given that this is a straight line demand curve, what price is this?
80.
It is 8, right? So down 2, because a slope of 2. And then what is this number here? 180. So we're going up by 40 each time, right? So a linear demand curve would say that that's 8 and 140. And so now, let's calculate the elasticity for this new number. You guys are going to do this again to make sure you're doing it all right. So let's go from point A to C now, A to C. So now it's a price decrease, so your new numbers and old numbers have changed around. So calculate elasticity between A and C. What is your gut feeling of what it'll be? The same, right? That turns out not to be true. So go ahead and calculate it. It turns out not to be 1.8. And it's it seems a little strange. It seems like it should, but we'll talk about it once you calculate it. So calculate the elasticity of demand between A and C. So now your old number is 10 now, but your new number is 8. So we got a new number of 8, which means a new quantity with the orange here of 180. We're going from point A to C.
Can you write our new numbers on the side again?
Yeah. So A is the same, but now we've got a new price of 8 and a quantity of 180. As soon as you get a number, shout it out.
Negative 1.25.
Negative 1.25. Anybody get anything different so far? I'll give you a little bit more time. I want you guys to give you enough time to go ahead and get a number. Give you another minute here. If you got 1.25, raise your hand. Got another person. Jackson got it too, 1.25. Negative 1.
Negative 1.125.
125, okay. Negative 1.125. Anybody else get that one? We'll give you guys some time here to still keep going.
I got negative 1.125.
Oh, we got 2 checks for negative 1.125, and we actually had 2 checks for 1.25. It's a neck and neck race here. 180 minus 140 divided by 160 all over 8 minus 10 divided by the average of 9. So we get 40 over 160 all over negative 2 over 9. Let's see, we can get rid of those pesky zeros. 4 and 16 is 1/4 times 9 halves. Gives me 9/8 negative. And somebody with a calculator, 9 divided by 8. I know it's got a 1 in front of it.
1.125.
Under that 40 is
1.125?
Yeah.
Okay. Excuse me, go ahead, Rich.
Under the 40, is that 100 or is that 140?
Under the 40. Are you talking here? That was the average from 160. So this is 180 minus 140 divided by the average quantity, which is 160. So then I had 40 over 60. And then I was just doing some math because I didn't have a calculator. I just did it with the fractions. You guys could do it with your calculator, no big deal. So 9 divided by 8, 1.125. It looks like our winners are here. 1.25, did you guys want to challenge that, or did you get?
I just kept it like normal numbers. I didn't put them into fractions.
Oh, okay.
9 over 8. Like, I didn't break it down like that. I kept it at like the 40 divided by 60, whatever that number was as a decimal divided by the -2 over the.
Well, you should if you.
Oh,
I was gonna say if you did a decimal here, 40 divided by 160 and 2 divided by 9, you still should get that.
I don't remember.
You had to switch them around. Okay, all right. Any other questions on that? Okay, so now check this out. Let's what we're doing here back to this graph is we're saying between A and C, we've used the average of 160 and 9. So we're kind of saying that the elasticity estimated here is negative 1.125. And between A and B, kind of going in between where the averages are, the elasticity is equal to negative 1 point, was it just 1.8? Yeah. Okay, 1.8. And so the elasticity changes depending on where you measure it along a linear demand curve. It is going to change. In fact, what would it be if we went way over here? If we were like going from quantity 1 to quantity 2, quantity 1 to quantity 2, that's like doubling it, right? What percentage change is that? Roughly, just using even the old school. If you double something, what percent is it? 50%, 100%, 200%? If you double something, going from 1 to 2, 100%, right? It's 100% if you're doubling it. So it's like 2 minus 1 divided by, I'm doing the old one of 1. 1 over 1 is 100. So it's like 100%. So if we get to a really small quantity, and then also we look at a really high price, like let's say it's a price, I'm going to kind of go off chart here and say it's 100. If we go from $99 to $100, like roughly that's a 1% change in price, right? So if we were really, really, really close to here, and we look at our formula, we'd have a super huge number here and a really small number here, right? So as we move this way along here, the numbers are getting bigger in absolute value. I hate to bring that in because I think your textbook tries to avoid that, which I kind of love. But you get the number getting a lot bigger in negative terms, right? It's going up to infinity, actually. And then as we move down here, this path continues. They start to get really small because here it's $1 to $2 is like a super huge price change, and the quantity change is really small. So now this is super big, and this is super small, and we get just the opposite, right? So because we're doing the ratio of percentage changes, that's why this changes. Because the slope, as you guys know, doesn't change, right? That's why you thought maybe this was the same number. The slope is the same, but not the percentage change. And that causes the elasticity to vary along the linear demand curve. Okay, so interpreting this, I want you guys to kind of get good at this. We can kind of say, oh, take this number, how do we turn it into a fraction? Put it over 1. And then just, you got to have kind of that formula memorized. And now the 1 goes here, a 1% increase in price leads to a 1.125% decrease in quantity demanded. So it gives you a really nice way to interpret that number. Okay. Let's see. Maybe I'll try it the old school way while I do this. Trying to trick the projector into working the way I want it to work. All right. Any questions? So there's lots of different ways to characterize this. So with a flat demand curve, a lot of the numbers are going to be bigger than 1. So how to label the elasticity of demand? How to label the elasticity of demand. So the numbers we just did, if the elasticity of demand is greater than 1, this is where it gets a little tricky with it. Let me see if, remember I told you we did switch textbooks, but this is where it starts to get a little interesting. Oh, here they do use 1 elastic. Okay, I'm going to take a stab at it. Who remembers absolute value? It's kind of easy, but it's, you know, I don't mean to be throwing extra math if I don't have to, but I feel like I have to. Absolute value, what do you do with the number to absolute value? Caleb?
If it's negative, it's positive.
If it's negative, it's positive. If it's positive, it stays positive, right? So it was kind of a dumb little thing, but a mathematical way. It helps us get rid of this with the size. So the absolute value of the elasticity, we already know that it's negative, right? So all we're saying is we're going to talk about it as a positive. This is something that's been done to principal students for years, and this is about probably the only reason why. So this is the absolute value. Why? Because we know it's negative. So if that negative, but now positive number, if that has a value greater than 1, what does that imply? That means that the percentage change in quantity, the upstairs of the formula, is bigger than the downstairs. A 1% change led to a 1.125% change. A 1% change led to a 1.8% change, right? So this effect is bigger than this effect. And so this means we've got responsiveness, right? Responsiveness. They're changing their quantities more than they're changing their price. So when it's greater than 1, we have responsiveness, which means it is elastic demand. Relatively elastic demand. All right, well that number can be negative too. So if the number, I'm sorry, not negative, less than 1, if our formula comes out less than 1, where we have a super big thing on the bottom and less up top, then the opposite is true. The responsiveness of consumers is pretty small compared to the price change. So the upstairs is smaller than the downstairs. So consumers are like unresponsive. Maybe because we're looking at cocaine and they're just stoned out of their mind or something. They're like, oh, I don't really care. I don't really care what the price is, right? Responsiveness. So unresponsive, I guess is what I'm going to say without the S. Unresponsive, relatively speaking. And so that means we are relatively inelastic demand. All right, any questions? Everybody getting what I'm saying here? We're kind of looking at one as being the pivotal point of calling something inelastic or elastic. And then there's one last one that's kind of a weirdo one, but it can come up especially as we get close. What if it was equal to 1, right? If it's equal to 1, then it says a 1% change leads to a 1% change, or a 10% change leads to a 10% change. So we're right at where they're equal. So that would mean that the two are equal. And we call that case unitary elastic. Unitary elastic. Okay, let me get this thing rocking and rolling again. It scared me. I actually thought it might come down all the way this time. Okay, so I wanted to show you some of the different price elasticities. This thing can cook up. There we go. %, warming up. Come on. All right. This is just right out of your textbook. So let's start over here. So these are goods that are inelastic. Salt, matches, toothpicks, airline travel, gasoline, natural gas for heating your house, coffee, fish, tobacco, legal services in the short run, physician services, doctor services, right? Dental services, a taxi, Uber X rides. Oops, sorry, I'm off the table here. Uber X rides, automobiles. So all of these numbers are less than 1 in absolute value. So tell me about salt. Why is salt inelastic, right? Consumers are unresponsive to salt. Why? That's a We got a lot of salt mines. No, that would get a little bit more on the production side, so you kind of have a business hat on.
Nobody looks at the price.
What's that, Rich?
Nobody looks at the price, they just buy salt.
Okay.
Unless it's that organic stuff that's like $9.
Okay, well there, you just picked up on a good point, right? So, in general, salt is low price. If salt starts to get to be $9, do you start to pay a little more attention to salt prices? Yeah, right? So, but if salt is $1 or $2, and it goes up from $2 to $2.20, do you give a darn? No. Better yet, if salt is priced at $2 and it falls in price to $1.80, do you go run out and start stockpiling salt? No. You only eat so much salt, right? In fact, your doctor might tell you should cut back on salt, that it's not the thing that you should start consuming more of, right? So the nature of the good lends itself to being kind of unresponsive. That's our demand curve like this, right? So if you lower the price of salt, I'm probably not going to buy a bunch more. If you raise the price of salt, I'm not going to cut back a lot, right? It's relatively unresponsive, those changes in salt. And so a lot of these things can be pretty small in terms of our fraction of income. So one of the things that impacts our elasticity of demand is the fraction of income spent on the good. So let's put that, we're going to start that list here. So things that affect the value of the elasticity of demand. Number one is the fraction of income spent on the good. So even if you're making $40,000 a year, salt is a pretty small purchase. So example, salt. Let's just go ahead and put gum, bubble gum at the cash register. Right? If those goods are a small fraction, so basically you don't care about a 20 cent rise from $2. It's like, 20 cents, I make 40 grand a year. Yes, I'm not rich, but at the same time, it's freaking 20 cents, right? So the smaller the fraction, let me just say it the way we've done it here, I guess. The larger the, the smaller the fraction of income, the greater, or the smaller the elasticity, the more inelastic. Okay, so let's put that one down here just for smaller fraction. The smaller the fraction leads to less elastic. Now I'm intentionally kind of throwing those words around a little bit. Less, because you're going to see this on your homework and test. Less elastic means more inelastic. Right? So kind of be able to go both ways because you might see that. So less elastic, I'll just put here, means more inelastic. Got to be a little versatile going both ways with that. Okay. Questions or comments there? So what's on this side of the fence over here? So here's the unitary elastic. Movies, housing, owner-occupied in the long run, so over a longer period of time. Shellfish, so that'd be like shrimp and maybe some other things that have a shell. Some seafood, oysters for some reason. I don't know what the seafood theme is. Private education, tires, televisions. So when they estimate those, they tend to be around 1. So they're close to getting a similar bump. 10% price increase leads to a 10% price or quantity decrease. And then elastic. Restaurant meals. If restaurant meals climb by 20%, what do? Don't go out as much, right? Eat at home one more meal. It's not like you give up going out to eat, but instead of going out to eat 4 times a week, you go out to eat 3 times a week. That's like a 25% reduction in restaurant meals, right? So you're pretty responsive to price changes with restaurant meals. So foreign travel, airline, long run, fresh green peas, automobiles, Chevrolet automobiles. I mean, I'm guessing they put Chevrolet because they did a study on this. But what would happen if we looked at the elasticity, which has been done many, many times, by the way, for U.S. American automobiles? Would that number be higher in absolute value, like a 5, or would it be now a 2 or something? Higher or lower in absolute value if we look at U.S. automobiles as opposed to Chevy automobiles? Lower. Does everybody agree with that? Okay, why? That's correct.
Because we have a lot of U.S. automobile makers, so you can always interchange
So you can interchange. Good. You brought it back to what is going to be number 2 on this list, which probably should be number 1 because it's probably the most important one. And that is the availability of substitutes. So number 2, that'll affect the elasticity, is the availability of substitutes. Availability of substitutes. So example, Chevy versus US Autos. A Chevy has a lot of substitutes, including Ford and GM. I'm sorry, Dodge and Chrysler products, right? Plus all the Toyotas and BMWs and Nissans and all the cars from around the world. So Chevy has more substitutes. This includes Chevy. So when we define a good U.S. automobile more narrowly, right, it opens up more substitutes. If we define it more narrowly, it opens up more substitutes. Okay, and so with more substitutes, we get more elastic demand. So more substitutes means more elastic demand, which is a flatter demand curve. Visually, when we draw the demand curve, it would be a flatter demand curve, more elastic. So same thing's kind of going on here with the amount of time allowed. So if you look here, airline travel 2.4, but here we had airline travel 2, 0.01. What's the only thing that's distinguishing the difference here?
Short run.
Short run, long run. So if you need to get somewhere in the next month and prices go up, can you change your plans pretty fast? No, you're kind of stuck with paying the extra price. But if prices go up in 6 months later, if we look at your decisions, maybe you decide to drive, right? A few of you might decide to drive if we open up the time horizon longer. So the last one here to put on is the length of time. Length of time. So airline travel, short run versus long run. I better write that out this time. We'll be using that abbreviation later. What did they called it? Short run. Yeah, good. Short run versus long run. So the idea here is, in the short run, you're stuck, perhaps, or you're more stuck. In the long run, maybe you can drive or change your plans around, shop around other airlines. So you've got more time to find substitutes. So it always kind of plays back to substitutes to some degree here. You got more time to do it, and so when the short run, it's less elastic. Sorry, I'm getting kind of small here. Less elastic in the short run, more elastic in the long run. And that's what this table of numbers is showing. The number's big, 2.4. In the long run, when we have time to find substitutes, but in a shorter time horizon, the airlines can probably jack up the price and you're still going to fly with them, right? Okay, questions or comments there? So iPhone apps, that's kind of interesting. They charge $1. I'm sure they've done little studies on, it's pretty easy to do a little, what we call an economic experiment. They could allow some iPhone users to get $1 for an app, and other iPhone users have to pay $1.50. They don't even tell you they're doing this, but I guarantee you that they've experimented with that to see what the sensitivity is of buying or dumping the app. If I let that out in half the country at $1 and half the country at $1.50, what's the response rate between the two, right? So we can have some variances to establish what the elasticity is. Okay, any questions or comments there? All right. Bye-bye screen. So let's bring this back to why this is important for businesses to know. They want to know how much money you're going to spend on a good at different prices. So what is the profit equation? Profit equals, this is one that should be rolling off your tongues, get it ready. I'm going to hit you with this a lot over the next 2 weeks especially. Profit, I want everybody to have that formula off the top of their head. What is it? I know he told you, but now I want to see if you listen.
I didn't understand what he said. What he said.
What's your name?
Will.
Will, okay. So, how does a company make, so imagine we've got a lemonade stand. All right, and so my son used to sell lemonade at the bottom of our stairs because we were right by the football stadium. So on that day, he sold 150 glasses of lemonade at $1 each. What was his profit? 150 glasses of lemonade at $1 each. 150 is how much money he's holding at the end of the day.
Yeah.
Is that his profit?
No.
What would need to be adjusted? Hold on, Rich, I'm working with Will.
How much all this stuff costs.
How much all that stuff costs. Good. So I kind of led you down a path. I was expecting you to say 150 just to kind of help remind ourselves that there's another part to the equation. It's not all about revenues, but also about the cost. So profit equals total revenue. This is the one I want rolling off all your tongues here at some point. Total revenue minus total cost. Total revenue minus total cost. And what Will did in his head was price times quantity, right? The price of the lemonade was $1, the quantity was 150. So the equation for total revenue is price times quantity, and then we'll just leave total cost by itself there. Okay, so I bring that to your attention to kind of call up one of my favorite graphs, probably my favorite graph, the favorite graph of economics. So we're going to stack two graphs on top of each other. They're going to be connected vertically this time. And so upstairs we have a regular old demand curve. And I'd like you to make sure it touches the horizontal and vertical axis. So just draw a demand curve, maybe it looks like that. Just make sure that it touches both the vertical and horizontal axis. Okay. So down below, we are going to be mapping out total revenue. So total revenue is going to be the vertical axis variable. And remember, it's price times quantity. Just kind of rewriting the formula. Total money in the cash register at the end of the day is the price of our product times the number of units that we sold. And then on the horizontal axis, again, sorry I'm getting a little low here, but if this is 1,000, let's just say that the demand curve intersects your horizontal axis wherever you guys did it, put it at 1,000. how these two graphs relate to each other is that this is 1,000. Okay, I gotta get rid of this line because it's a bother. Gotta at least run parallel with the board here. There we go. That's a little better. All right, so if the company, my son, prices the lemonade at $1,000, how much lemonade does he sell even with drunk people walking up and down the street to go to the Iowa State University football game? 0, right? So at a really, really high price, nobody's going to buy is what the law of demand says. And so price times quantity, 1,000 times 0 is 0. So at this price, we're down at the origin here in terms of the amount of revenue. Now, as the price falls, then we start to sell more product, right? And so we lower our price and revenues start to climb because we start to sell some more product, right? So that's going to start going up at this point. And then as we move down to this spot here, if I price my product at 0, will a lot of people want it? Yes, that's a great price. A lot of people love free things, right? So a 0 price is great, but how much money is in the cash register at the end of the day? 0. So this price ends up being the other anchoring spot for total revenue. All right, so now what does the middle, what does the guts look like? This is the interesting part of this. All right, so on your paper, this is a little trick that I'll tell you more about later, but I want you to find the midpoint between where the demand curve intersects the horizontal axis and the origin up on the demand curve. Find your middle point. You can just eyeball it. You don't need to get out a ruler or anything. Just kind of eyeball the middle, and then come down and just make a point, and you've just helped to create what I call revenue mountain. So the top of revenue mountain is right at that midpoint. Okay, so what does this say? As you decrease price, revenues start to go up, but that doesn't last forever. Eventually, you make prices so low that your money in the cash register starts to fall. And that's because of the relationship of the elasticities. So over here, the next part I want you to do is go up to the demand curve, make another point, straight vertical, and that is where we have the unitary elastic. That's where it's equal to 1. The elasticity in absolute value equals 1. That's going to split things up. Okay, so to the left over here, we have big quantity changes and small price changes. So the upstairs is bigger than the downstairs for our elasticity formula. Let me rewrite that for you. It's in your notes there somewhere. But when I talk about the upstairs and downstairs, I'm back to this formula. Over here, the quantity changes are big and the price change is small. And so this is the elastic range of the demand curve. All the numbers are bigger than 1. So this is the elastic range, where the absolute value of the elasticity is bigger than 1. So that was our airline travel in the long run. It was the Chevy automobiles, all of that stuff. That's the elastic range. And then finally, this lower section here, the upstairs is smaller than the downstairs, and now we start to get inelastic. So this is the inelastic range, where the absolute value of the elasticity is less than 1. Okay, so This little graph is pretty helpful in answering about 1,000 homework and test problems all in one with this picture. So that the problem would go something like this. If demand is elastic and you increase price, what happens to total revenues? So you can answer that question with this picture. All right, so let's kind of see how this thing works. If we take points A and B, and let's just say that this is a $12 to $10 change, so a $2 price decrease, what happens to total revenue? Well, this is how this sucker works. At point A, that corresponds with a point, let's call it A prime, down on revenue mountain. And B corresponds with point B prime on revenue mountain. And so a decrease in price in the elastic range leads to an increase in total revenues. You're going to have more money in the cash register at the end of your lemonade sales than you did before if demand was elastic and you cut the price. You're going to have more money in the cash register at the end of the day. Now on the flip side here, if we come down to points C and D, so here's point C, and here's point D. And let's say this is at, I don't know, 4 to 2. I know this isn't exactly drawn to scale, but the point I want to make is that we're doing a $2 price change, the same thing we did up here. We're dropping price by $2. But now that price effect is pretty significant, right? In terms of percentage changes, it's like cutting your price in half. And so on points C and D, when you do that, that corresponds with points C prime and D prime on revenue mountain. And that means that when you cut the price in the inelastic range, you've got less money in the cash register at the end of the day. So total revenues will fall. All right, let's see how good you're doing. Let's do an example. If demand is inelastic, and you increase price, what will happen to total revenues? So this is how it would look in print on your homework or test. If demand is inelastic and you increase price, you're not going to have this graph to look at, right? So this is where having that graph kind of memorized can help you answer that. What's the answer? Is it going to go up or down? If demand is inelastic and you increase the price, what happens to total revenue? Jackson? It increases. Good. I heard some other ups. So now we're basically just reversing this D to C. We're going up. So total revenues will go up. Woo! All right, we'll call it a day there. We'll see you on Thursday. That's pretty close to wrapping up this chapter 20. Got a few more things to talk about. We're almost there. See you Thursday. Assuming it's not Snowmageddon.